Okay, this is problem number 4 from the test review. A hardware manufacturer produces bolts used to assemble various machines. Assume that the diameter of the bolts produced by this manufacturer is normally distributed as advertised to have a mean of 5 millimeters with a standard deviation of 0.1. So this is what they're supposed to have. Suppose that the average diameter of a simple random sample, so we took a sample and the sample had an average 50.03 millimeters. At the 1% level, is there enough evidence to conclude that the bolts are different from 5 millimeters? All right, so we need the very first thing to do is use our recipe. Number 1 says that we need to go ahead and write our null and alternative hypothesis. So the claim is that they're producing 5 millimeter bolts. So HO mu equals 5 millimeters. Excuse me. The alternative is mu and 5 millimeters. And now we need to make a choice between less than, greater than, or not equal to. Well, they didn't say less than, they didn't say greater than or more or anything like that. They said different. When you have the keyword different, that means not equal to. The next thing we need to do is define the parameter in context. So number 2, let mu equal the true population mean diameter of bolt, and technically they're in millimeters, but we're going to say let mu equal the true population mean diameter of the bolts. They said a random sample was taken. They also mentioned that it was normally distributed, and we're going to sit there and go ahead and just say that the assumptions or the conditions are assumed to be met. So we just write assume. Number 4 is to write the actual equation. So Z equals x bar minus mu sigma divided by the square root of n. Draw the graph in shades. So this is number 5. So here's what we have. We have a claim, and remember our graph is always centered on the claim, and the claim is that it's 5 millimeters. That's our mean. But we ended up getting a sample mean that's larger. So this is our x bar. This came from the sample, which is 5.03. Please remember the sample value. So if you can label it x bar, will never ever go here. All right. It'll never, the x bar values will never go over here. So that may help in writing your null and alternative hypothesis. The next thing says enter the data. If given, we didn't have any data. So then we need to make a list of all of our inputs. So we have a mean equal to 5 millimeters because that's what the claim is. We have a standard deviation of 0.1 millimeters. We have an x bar equal to 5.03. And we have a sample size of size 50. Okay. So now we've done that. It says we're going to, part 8 is going to be plug into the equation. So this is going to be the probability that Z, oh, since this is a not equal to, anytime it's a not equal to, that's a weird question. All right, anytime you have a not equal to, you're going to put 2 times. And since we shade it up, this is going to be greater than. Just put a 2 in front, 2 times the probability that Z is greater than. And you don't have to do anything with that other than to write it there. That's all you need to do because the calculator will do the work behind the scenes. So this is going to be 5.03 minus 5 millimeters over 0.1 divided by the square root of 50. All right, so that's number 8. Because we've gone and plugged the values into the equations. And number 9 says we're going to go ahead and calculate our z-score. So I'm going to do that by going to stat test. Number 1 happens to be z-test, and that's what I want. And the first thing it asked for was my mean, which was 5. My standard deviation is 0.1. My x bar is 5.03. And my n happens to be 50. Now, what did we use? We used not equal to as our alternative, so that's what we're going to plug in, not equal to. Make sure that's highlighted. When we do that, I have an error, stat, test, z-test. My x bar is 5.03. All right. Now let's see what happens. So I end up with the probability that z is greater than 2.1213, and that equals my p-value of 0.0338. All right, so this is my p-value, so let's label it as such. And we have an alpha value equal to 0.01. I'm going to run this one more time to make sure I have my data right. Stats, test, z-test. Everything looks pretty good. So 0.01 is my alpha. Now I need to make these the same length. So this is 1, 2, 3, 4 digits. So I need to add 2 more zeros to have the same length. Well, 338 is definitely greater than 100. 338 is definitely greater than 100. And so then I look at the next thing it says is, well, what's my decision? Well, according to the recipe, if the p-value, this is on number 10, if the p-value is greater than alpha, we fail to reject. So number 10, we're going to fail to reject. That's going to be our decision. All right, so now we need to write the conclusion. And we're going to do this based on our failure to reject. So number 11, our p value is, in this case, 0.0338. We fail to reject the null. There is sufficient evidence at alpha equal 0.01. That was our alpha level. Excuse me. There is, remember we failed to reject. So there is not, please don't forget the not, because that makes all the difference in the world. There is not sufficient evidence at alpha equal 0.01 to suggest that the true population mean bolt diameter is, and then what did we have up here? Not equal to, well, that's the word different, is different than 5 millimeters. So let's read that again. Our p-value is 0.003 or 0.0338. We failed to reject the null, which is what we said here. There is not, don't forget that not, sufficient evidence that alpha equal 0.01 to suggest that the true population mean bolt diameter is different than 5 millimeters. And please remember that just came right here off the recipe. Our p-value is whatever we said, 0.0338. We failed to reject the null. There is not sufficient evidence that alpha equal, we said 0.01, to suggest that the true population mean for the bolt diameter is, in our alternative, different than 5 millimeters. Okay, the next thing says construct a 90% confidence interval. Now, I'm going to be a little bit crowded here, so I'm going to use a separate sheet of paper to go ahead and do this on a separate sheet of paper. So on the separate sheet of paper, we've already, when I look at the recipe, the very first thing says define the parameter. So number one, we've already done. All right. The conditions we've already done because we said that they're assumed. Number three says write the equation or write the formula for this test. And the formula is different this time. It's going to be an X bar plus or minus. I say it's different than a hypothesis test, I should say. X bar plus or minus the standard deviation divided by square root of n. Number four, enter data if given. We don't have data. So number five is identify all of our inputs. So in this case, our first input is the standard deviation, which happens to be the same as what we had earlier, which is 0.1 millimeters. And I just got that from the problem. The next thing it asks for is it asks for the X bar. Well, our X bar in this case was 5.03 millimeters. And then we need our sample size, which is 50. And in case you were wondering how I got those so easily, we already wrote them down up here. So I just copied those again. All right, those are the same values that I had before. All right, then number 6 on that same problem says calculate Z star. Calculating Z star may be the most difficult part of the whole operation because we're going to need to do 1 minus the confidence level. All right, so we're going to go, in this case, 1 minus, and our confidence level was 90%. So 1 minus 0.90, these need to be in parentheses, divided by 2. And this is going to be an inverse norm. All right, this is going to be an inverse norm. And what this really looks like, even though it didn't ask you to do it, looks like this. We have a 0.90. And we're going to be looking for a lower bound and an upper bound. And so we're going to do 1 minus 0.90, and we're going to get this one, and we're going to get this one. Now we're just going to make these positive because it just makes it easier. So the second bar is inverse norm. And for the area, I'm going to go 1 minus 0.90, close parenthesis, divided by 2. Mean is 0, standard deviation of 1. And I'm going to end up getting a negative, but we're going to go ahead and make it positive. Just makes life easier. So Z star equals 1.6448. So now it says plug in those values. So this is for number 7. So X bar is 5.03 plus or minus 1.6448. Standard deviation 0.1 divided by the square root of 50. So it should look something like that. Number 8 says write the interval. Well, in this case, I'm going to go, I need to calculate it first. So to do that, I'm going to go stat, test, And I'm going to drop down to number 7, which is Z interval. So you're going to scroll down to Z interval. My mean in this, my standard deviation in this case, we said it was 0.1. My X bar is 5.03. My N was 50. And I'm going to change my confidence level to 0.90. And so there I end up getting my confidence level of 5.0067, comma, 5.0533. So there's my confidence interval. So now I have to write my, I'm going to have to write my conclusion. And my conclusion is, and this is number 8, or number 9, excuse me. This was at number 8, this is number 9. We are 90% confident that the true population mean for, well, what was it? Well, we said mean population mean bolt diameter lies within the interval 5.0067 to 5.0533. All right. The next thing is, it did say, and interpret the confidence level. Whenever it says interpret the confidence level, I have to do step 10. All right. So we're going to have to do step 10, which is in repeated sampling, we expect that this method will capture the true population mean bolt, bolt, looks like bolt diameter 90% of the time. All right. So this is our conclusion. We have to do it every time, but if they ask us to explain the confidence level, we have to do this. Then it says, based on our interval, can it be concluded that the bolts are being produced are 5 millimeters? Justify your response. Well, that's a really good question. Can we make that conclusion? Well, when I look at this, what was my interval first off? 5.0067. Well, that's above. So my lowest value is above 5 millimeters. So 5 millimeters is not in the interval. Therefore, we can conclude that the process is not making bolts at 5 millimeters. So based on our interval, can it be concluded that the bolts being produced are 5 millimeters? And the answer is no. 5 millimeters does not lie in the interval. So 5 millimeters is not a plausible or reasonable diameter because the interval, and the interval is above 5 millimeters because we had an interval of 5.0067. So 5 millimeters is somewhere down here. So it's somewhere over here. So this interval lies above it. So because the interval lies above 5 millimeters, because the interval lies above 5 millimeters, the bolts, the mean bolt diameter is greater than 5 millimeters. Because the interval is bigger than 5 millimeters and doesn't contain it, then we know that the bolts being produced are larger than 5 millimeters. Now, if it contained it, then we could say that if it contained it, then we could say that 5 millimeters is possible. As it is, the largest plausible answer the bolts could be is here's my interval. The smallest one plausible answer is 5.0067, and the largest plausible answer that the bolts could be is 5.0533. So nothing larger than this and nothing smaller than that. So 5 was smaller, so the 5 millimeters is smaller, so not producing 5 millimeter bolts. Okay. Next video will cover problem 5.